Welcome to this lesson on giant covalent structures. By the end of this session, you will understand what giant covalent structures are, how their bonding works, and why they have unique properties. Let's dive in. In covalent bonding, atoms share electrons to achieve a stable outer shell. Normally, this gives us small molecules like water and carbon dioxide. But sometimes, the covalent bonds continue endlessly, forming giant covalent structures. A giant covalent structure is a huge network of atoms, all connected by covalent bonds. Unlike small molecules, there is no fixed number of atoms. Famous examples are diamond, graphite, and silicon dioxide. When you are asked to define giant covalent structure, always link the property to the strong covalent bonds in your answer. Let's take a look at diamond and its properties. In diamond, each carbon atom forms 4 covalent bonds. This creates a rigid 3-dimensional lattice with a tetrahedral shape. The structure explains its strength and hardness. Diamond is the hardest natural substance. It has a very high melting point because a lot of energy is needed to break the covalent bonds. It does not conduct electricity because it has no free electrons. Students, if you are asked in exam to explain why diamond is hard, always mention the 4 strong covalent bonds per carbon atom. Because of its hardness, diamond is used in cutting tools and drill bits. It is also valued in jewelry for its sparkle. Let's take a look at graphite. Graphite is different. Each carbon atom forms 3 bonds, leaving 1 free electron. The atoms form flat layers of hexagons. These layers are held together by weak forces. Because the layers can slide over each other, graphite is slippery and soft, useful as a lubricant. It conducts electricity because of the free electrons that move through the structure. It also has a high melting point due to strong covalent bonds in each layer. In exam, if asked why graphite conducts electricity, say it has delocalized electrons. And if you are asked why graphite is used as a lubricant, say it's because the layers can slide over each other, so graphite is slippery and soft. Graphite's slippery nature makes it a good lubricant. Its ability to conduct electricity means it is used in electrodes. And mixed with clay, it forms pencil lead. Let's take a look at a single layer of graphite called graphene. Graphene is a single layer of carbon atoms arranged in hexagons. It is only 1 atom thick, making it extremely light, yet it is about 200 times stronger than steel. Graphene is an excellent conductor of electricity and heat, which makes it useful in electronics, batteries, and medical applications. In exams, if asked about graphene, always mention that it is a single layer of graphite and that its strength and conductivity make it unique. The last giant molecule which we will be looking at is silicon dioxide. Silicon dioxide, or silica, is another giant covalent structure. Each silicon atom bonds with 4 oxygen atoms. Each oxygen bonds with 2 silicon atoms. This creates a very strong lattice. Silicon dioxide is hard and strong. It has a very high melting point because of the many strong covalent bonds. It is insoluble in water. Just like diamond, silicon oxide is a non-conductor of electricity. Let us compare them. Diamond is hard but does not conduct electricity. Graphite is soft and does conduct electricity. Silicon dioxide is hard and does not conduct electricity. Exam tip. Examiners often ask for similarities and differences, so practice comparing them directly. Let us answer an IGCSE past paper. Figure 8.2 shows the structure of graphite. 1. State the type of bonding in graphite. 2. Explain by referring to Figure 8.2 why graphite is used as a lubricant. 3. Graphite and diamond are both forms of carbon. State one use of diamond. You can pause to give it a try. Here are the answers to the questions. Let's take a moment to test your understanding of what we've covered so far. Please choose the correct answers to the following questions. You can pause the video if you need more time and also re-watch to answer the questions. To summarize, giant covalent structures are networks of atoms held by strong covalent bonds. Important examples are diamond, graphite, and silicon dioxide. They share properties like very high melting points, but differ in hardness and electrical conductivity. Thank you for learning with AceStudents. If you found this lesson helpful, be sure to check out our playlist for more videos. Every video includes evaluation questions to help you test your understanding. Our content is perfect for homeschooling, Google Classrooms, or private tutoring. Don't forget to subscribe and click the notification bell so you never miss a new science lesson.